So we're going to look at calculus. And calculus came about because somebody decided they needed to understand the gradient of functions. Now, we've not talked about that when we were doing graphs. We know what a gradient is. What's a gradient? Good. We don't know what a gradient. We do know what a gradient is. What is it? It's the rate of increase and decrease is a perfect explanation. All right. Rise over run. How far up over how far across? The slope. M. Any of those things. That's what we've been doing as a gradient. All right. So way back when you were in year, I don't know, 10, something like that, you learned to draw a line. You learned that this was the y-intercept, and you learned that the distance up over the distance across, that ratio is m, which is the gradient. Rise over run, if you have one person. If you had me, which you did, most of you did, up over across. Up over across right, so we're always moving that way. So that could be down. All right, up and down, over, across, right. So that's what the gradient is. It measures the slope of something. But if we have a curve, what's that graph? Parabola. Good, we know it's a parabola. What's the gradient going to be? Well, here the gradient is 0. Here the gradient is about 1. Here the gradient is about, yeah. Here the gradient is about, all right. So we've got lots of gradients on a curve. But we need to understand those gradients because they are telling us something. And what they're telling us, we'll go into a bit further on. So the gradient there is 0. The gradient here is about 1. The gradient up here, we decided might have been 3. All right, over here, maybe -1. Maybe -3. All right, and we've got half as well down here, and a quarter, getting closer and closer. We've got pretty much everything that's a gradient on this parabola. So what we want to do is be able to find out a way of knowing what the gradient actually is. But what you can do is you can estimate the gradient. And there's 2 ways of doing this. Let's say we have, I'm going to keep going with this, but I think it's probably the first question in the book. Anyway. We know that we've got 1, 1, 2, 4, right? We know that those are the points. So if we wanted to find the gradient of a point at about halfway in between here, 1.5. Right? What we could do is we could find what the value of 1 is. So we could find this. Right? It would be close to the gradient at that point. So we could find the distance up over the distance across. So that would be so we want what the value of 2 is minus what the value of 1 is over 2 minus 1. So that's the difference here. So that's 1 across. And how far up? So that's 4 minus 1, which would be 3 over 1. So gradient at 1.5 could be around about 3. That's using just the power of investigation. All right? So if I had actually given you that job to do, some of you may have used that. Others of you may have used Now, what's tangent? Do you remember back to circles? 90 degrees, yeah. But it's a line that does what? Sits next to the circle. A tangent is a line that touches a curve at a point but doesn't go through it. So we could perhaps use the tangent here. So this is our point. If we draw this line that touches, and then we try and figure out the gradient of that. So we might have to go a fair way to find out a point. So that we could actually use. Who knows where it's going to be? We might have to go all the way up to here somewhere. But we could use these coordinates to find the gradient. So we can find up, over, across. So it touches it but doesn't go through it. And then we could try and work out the gradient of that point. It would be far more accurate, but it still would be, we'd be guesstimating numbers. We're going to learn to actually find it exactly, but for today we're going to learn to use these two methods. Okay.